Good morning, students. In previous class, we have learned what is symmetric matrix, what is skew symmetric matrix, and transpose and their properties. Isn't it? Now, let us see what is elementary operation of a matrix, and in this class, we will study elementary operation of a matrix and the inverse of a matrix. Okay, so now you know what is inverse. In real numbers, you have learned what is multiplicative inverse. Now you see here the multiplicative inverse of 1 by 2 is 2, and skew's multiplicative inverse is 1 by 2. So what is the product? What you get? You get 1. 1 is what? The multiplicative identity element. Now similarly, in matrices also. Now every square matrix, okay, there exists for every square matrix. Every square matrix can have what? Inverse of a matrix. Means every square matrix has its inverse. Only square matrices have what? Their inverses. Now, suppose if A is a matrix, then its inverse is denoted by like this. Okay, A to the power minus 1. It is not A to the power minus 1. Inverse of a matrix is denoted by this symbol. Okay. Now, when you multiply a matrix by its inverse or inverse by its matrix A, then what you get? You get the identity matrix. Okay, so identity matrix. Now A inverse of A is denoted by this symbol. So if you multiply a matrix by its inverse, you get R, that is identity matrix of same order. Means if A is a matrix of order 2, then the order of identity matrix will also be 2. So A inverse into A is equal to what? I. So now let us see what is, now you understood what is inverse of a matrix. Means in general, if A is a matrix of order m, and then B is also a matrix of order m, then if AB is equal to BA is equal to I, B into A is equal to I, then you can say that B is, okay, B is inverse of A, and then in this case A is inverse of B. So therefore, inverse of A to B or B into A is equal to I, then we can say that A is inverse of B and B is inverse of A. Okay, see, B is inverse of A or A is inverse of B. Then means why? Why? Because their product is equal to what? I. So then only we can say that A is inverse of B or B is inverse of A. Okay. Now, before learning how to find the inverse of a matrix, you have to learn some elementary operation. What are those elementary operations? First operation is, okay. Now, so to find the inverse of a matrix, we have to learn some elementary operation. So what are those elementary operations? First one. So first one is what? You can interchange any two rows. Okay, you can interchange any two rows. Okay, any two rows you can interchange, and you can change what? Columns also. You can change columns also. Any two rows or any two columns. Now if it is a 2 by 2 matrix, let us say 1, 2, 3, 4 is a 2 by 2 matrix. Okay, then we can interchange R1 to R2. This shows what? R2 is coming in R1 place, R1 is coming in R2 place. Now what we can write here? This one we can write it as 3, 4, 1, 2. Yes, interchange R1 to R2, this symbol. Now similarly, we can interchange columns also. Here C1 to C2. So this is C1 to C2. Means we can interchange C2 to C1, C1 to C2. This symbol shows C2 to C1 and C1 to C2. How we can write this? 2, 4, 1, 3. Okay, 2, 4, 1, 3. So this is what the first elementary operation means. Actually there are 6 elementary operations. Here this is what? Means 3 for rows and 3 for columns. 3 for rows and 3 for columns. So this is first elementary operation. Means we can interchange any two rows and any two columns. So what is the second one? Second one is we can multiply all the elements of any row or any column by a non-zero constant. Means suppose if A is a matrix with elements A, B, C, D. Okay, now let us say here. Then now I am multiplying R1 by some what first row, elements of first row by 2. So means we are applying for R1. So we have to write R1 to R1 now. So after multiplying all the elements of R1 by 2, what we are getting here 2A and then 2B, and this we have to write second row as it is, that is CD. Okay. Now similarly we can multiply all the elements of any column by a non-zero constant. Now if you want, now you see I will multiply the second column by a constant, say what, 3. Okay. Now you see, yes, this one I am applying in R2 C2, therefore you have to write this one, in which means you are multiplying all the elements of C2 by 3, so you have to write like this. So now first column as it is, so AC. Now you are multiplying all the elements of C2 by 3, so what you get, 3B and 3D. Okay, so this is what the second elementary operation. Now what is the third elementary operation? Okay, what is the third elementary operation? The third elementary operation is we can multiply any row by a constant and we can add to its next row. Means now you see, suppose for example now 7 and 8. Now what I will do, I will multiply what first row by K, okay, any number only will take, that is multiply all the elements of R1 by 3 and we are adding it to R2. So here what I do, R2, now I am multiplying R2 plus, I am multiplying all the elements of R1 by 3, okay, all the elements of R1 by 3 and adding it to R2. We are applying it for R2, so therefore we have to write R2 plus 3R1. So now first row as it is, now 1 to now 7. 7 plus, now I am multiplying by 3, so 7 plus 3, 3 1s are 3. Now 8 plus, okay, now 2 3s are 6, isn't it? 2 3s are 6. So what will be the matrix? 1 2 10 and 14. Okay. So now this is what, now it is not completed, you have to add only and subtract also. Okay. So this is what the third elementary operation. Okay. This is what third elementary operation. Listen carefully here. Now what I am doing, I am applying. This means why you can ask why we are doing it only R2. Means you can do it R1 also. But means just you have to understand what is the elementary operation. These elementary operations are used to find the inverse of the matrix. So that's why we are learning all these elementary operations. Now I am applying here in R2. Therefore R2 plus 3R1. So now we cannot add same element where the elements of R1 is R1 only. Either we can add R1 to R2, R2 to R1. Now here R2 plus 3R1. So 7 plus 3 times of R1, that is 3 1 is 3. Now 8 plus 3 2s are 6. So what is the matrix? Matrix is we will get a matrix with element 1 2 10 and 14. So this is what the third elementary operation. Okay, this is what the third elementary operation. Now let us see how to let us learn one important theorem. Okay, now you see, if A and B are invertible matrices of same order, okay, invertible matrices of same order, then AB whole inverse equal to B inverse into A inverse. Okay, B inverse into A inverse. This is very important property, students. So please understand, it is very easy to remember. It is like what? Transpose only. Now you know that AB whole dash is equal to what? B dash into A dash. So similarly for what? Inverse also. That is AB whole inverse is equal to what? B inverse into A inverse. Let us prove it. Now you know that already. That is, if you multiply a matrix by its inverse, what you get? You will get an identity matrix. So therefore here, now what I will do? I will consider this as one matrix. So I will write it as AB into AB whole inverse. Okay, AB into AB whole inverse is equal to I, isn't it? And why I am writing I, you understood? Because on the left side of I only. You cannot take A inverse on the right side of I. Now we will change these brackets. Now you know that the multiplication of matrices satisfies associative property. So B into AB whole inverse is equal to A inverse into I is nothing but A inverse only. Now A inverse into I is I, correct? I into B into AB whole inverse is equal to what? A inverse. Now I into B is nothing but B. So B into AB whole inverse is equal to A inverse. Okay. Now we have to cancel this B. How to cancel this B? Now what I will do? I will multiply both sides by B inverse. So B inverse into B. Okay. B inverse into B into AB whole inverse equal to B inverse into A inverse. Now I am multiplying both sides by B inverse. So B inverse into B is nothing but I into AB whole inverse is equal to what? B inverse into A inverse. B inverse into A inverse. So I into nothing but I into anything is same matrix you get. So AB whole inverse is equal to B inverse into A inverse. Okay. So this is what the important. This is the proof for this theorem. So AB whole inverse is equal to B inverse into A inverse. B inverse into A inverse.
Start.
Okay guys. Okay students. Now let us see how to find the inverse of a matrix by elementary row operation. Now as earlier I told you, you can find the inverse by what? Row operation, elementary row operation or elementary column operation. But here while you are finding the inverse by elementary row operation, you have to follow some step. Here you have to write, if you are using what row operation, then you have to write A is equal to I into A. Okay, A is equal to I into A. For this is for row operation. But if you are using column operation, then you have to write A is equal to A into I. Okay, A into I. Now this is for row operation and this is for column operation. Okay, this is for column operation. This is for now A is equal to I into A. Now let us solve an example. Let us solve an example. Now suppose here A is equal to 1, minus 1, 2 and 3. We will discuss one textbook question. Now you see A is equal to 1, minus 1, 2 and 3. Now we have to find the inverse of this matrix by elementary row operation. Elementary row operation. Now listen carefully here, student. Now if it is a 2 by 2 matrix, okay, if it is a 2 by 2 matrix, you have to follow some steps here. You have to follow some pattern. Here from this step to here, you have to go in this direction. Now you have to follow this pattern, then you will get easily, you will get answer easily. So here, now A is equal to I into A you will get. Now we have to continue the process till you get I in the left side. That is identity matrix in the left side. So now what you have to do? You have to write A is equal to I into A. So A is equal to I into A. What is A here? 1 minus 1, 2, 3 is equal to what is I? I is a identity matrix of order 2. Okay. Now this A you have to write it as it is. And it's very simple. Now just you have to listen carefully. Now you have to, here I have told you have to use this pattern. Means what? Here you have to take, you have to make it 1 and then 0, 1 and then 0. Okay. Now if you follow this pattern, then you will get answer easily. Otherwise it will be more difficult. Means it will take more time to find out the inverse. Now what you have to do? Now already we have one is there here. Now we have to make it 0. How to make it 0? Now what I will do? I will subtract. I will multiply R1 by 2 and then subtract it from R2. Okay. So I am applying it R2. Okay. So R2 minus 2 R1. I will multiply all the elements of R1 by 2 and then subtract it from R2. So we have to apply this step for both, for this matrix also and for this matrix also. Now you see. Now first row as it is. Now second one. Now you see 2 minus 2 into 1 is 2. So 2 minus 2 is equal to 0. Correct? Now 3 minus 2 into minus 1 is what? Plus 2. So 3 plus 2 is equal to what? 5. Yes? 3 plus 2 is equal to 5. Same step here also. 0, 0 minus 2 R1. Now 1 first R1 as it is, then 0 minus 2 into this will be minus 2. Now 1 minus 2 into what? R1. R1 is 0, so therefore R1 element is 0. So what will get? Only 1. Correct? Now into A. This A as it is. Okay, you understood this step? So 0 minus 2 into 1, that is minus 2. Now 1 minus 0 into 2 is 0, so answer is 1. Now next step. Now what you have to do? We have to make it. Now we have to make this as 1. How to make this as 1? Now what I'll do? I'll multiply all the elements of R2 by 1. You understood? Now we are using elementary operation. Now we have to multiply R2 by what? 1 by 5. So R2. Now R2. We are applying it to R2. So R2 into R2 to 1 by 5 R2. So now 1 minus 1 0 5. Okay. Now that is equal to 1 0 minus. Now I am multiplying. So 1 by 5. 5 by 5 is 1. Okay. So now minus 2 by 5 and then 1 by 5. Correct? Now you see here I have divided or multiplied by 1 by 5. So 0 into 1 by 5 is 0. 5 into 1 by 5 is 1. Now here minus 2 into 1 by 5 is minus 2 by 5. 1 into 1 by 5 is 1 by 5 into 8. Okay. Now we got this one as 1. Now we have to make this element as 0 to get identity matrix. So when you will get this one as identity matrix, when you add what? R2 to R1, not R2 to R1, not what? Now you see 1 R1 plus R2, not R2 plus R1. If you do R2 plus R1, again this what? These elements will be disturbed. So therefore, what I will do? I will add R1 and R2, not R2 and R1. Okay. So now I am applying R1. So now 1 plus 0 is 1. Okay. Now minus 1 plus 1 is 0. Now R2 as it is. So 0 into 1 is equal to. Now 1. Sorry, R1 plus R2. So 1 plus minus 2 by 5 is nothing but 3 by 5. 0 plus 1 by 5 is 1 by 5. And then minus 2 by 5. And then 1 by 5 into A. So what is the inverse of the matrix? So A inverse is equal to. What is the inverse of this matrix then here? It is 3 by 5, 1 by 5, minus 2 by 5 and then 1 by 5. So the inverse of the given matrix is a matrix with elements 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. Now once again I will listen carefully. Now if it is a row transformation, we are finding the inverse of a matrix by row transformation, then you have to use this equation. Why we can ask why we are writing, why we have to write like this only? Because now it is for your syllabus, the explanation is not there, it is not there, just you have to remember this step. So A is equal to I into A. So A is given. So what is the given matrix? Is a matrix with element 1 minus 1, 2 and 3. So A is equal to I into A. Now, so we have to convert it as one identity matrix. So now by using elementary row operations. So now here for this you have to use this pattern. Now first element that is 1 and then from here to here you have to go, that is for A to 1 you make it 0 and then A to 2 you make it 1 and then what? A1 to 0. Okay. So now A11 is 1. Now we have to make it 0. How to make it 0? I will multiply all the elements of R1 by 2 and we subtract it from R2. I am applying in R2. So 2 minus what? 2 minus 2, it will be 0 and then 3 minus 2 into minus 1 is plus 2. So 3 plus 2 is equal to 5 and then same step here also. So 0 minus what? 2 into 1 is minus 2 and then 1 plus 1 minus 0 into 0 is 0. So answer will be 1 and this one is 8. Now we have to make it as 1. We are following this pattern. We have to make it as 1. How to make it as 1? So what I will do? I will divide by 5 or multiply by 1 by 5. We multiply R2 by 1 by 5. So R2 into 1 by 5 into R2. You cannot disturb what is column. You cannot multiply in columns here. We can we can use only what? Rows. So now I am multiplying R2 by 1 by 5. So what is getting? 0, 1 Now here also we have to multiply R2 to R2 by 1 by 5. So minus 2 into 1 by 5 is minus 2 by 5. 1 into 1 by 5 is 1 by 5. So R1 to R1 plus R2. Then now 1 plus 0 means you have to make it 0. So when you will get 0, when you add all the elements of R2 to R1. So when you get, you are getting identity matrix on the left side, and here 1 plus minus 2 by 5 is 3 by 5, 0 plus 1 by 5 is 1 by 5, and then the remaining elements of R2 are right as it is. So this means here, this in left side you are getting the identity matrix, means this should be the inverse of the matrix. So what is the inverse of the matrix? Inverse of the matrix is a matrix with the element 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. So now you can complete exercise 3.5.